Hello students, welcome back to my channel. Today I have picked questions from units and dimensions and kinematics. These questions have been extracted from the second shift 29th January 2023 JEE mains. Okay, so without wasting time, let us start solving. So here is the first question. As you can see, the equation of a circle is given by x square plus y square equal to a square, where a is the radius. If the equation is modified to change the origin other than 0, 0, then find out the correct dimensions of a and b in the equation. Alright, so we have to apply principle of homogeneity in dimensions, which states that two or more physical quantities can be added or subtracted if and only if they possess the same dimensional formula, or if they possess the same dimensions. So here you can see x is being added to at. So certainly the dimensional formula of x and at should match with each other. So I can write the dimensional formula for x is equivalent to that of a multiplied by t. So here after all a is the radius. So x and y must be the coordinates. Coordinate being the dimension L. So x can be replaced by L. Remember, here's a small area where students can commit mistakes. Here they have mentioned that t is denoted by 1 by t, that is t is not time, small t is not time here, it is the reciprocal of time. So I can write like this. So therefore a will be, dimensional formula of a will be lt. Then we got the answer, of course, because only second option has a equal to lt. You can see rest all the options for a are different. Anyway, calculate the, we'll find out the second one also. Again we can see that y is being, I mean t by b is being subtracted from y. So we can write the dimensional formula of y to be equivalent to that of t and b. So b will be equivalent to t by y. So t, small t is already given as 1 by t, y is already L. So Lt power minus 1. So this is the correct option. So correct option is the second option. Moving on to the next question. In an experiment measuring the refractive index of a glass using traveling microscope in physics lab, a student measures real thickness of the glass slab as this much and apparent thickness as this much. This is the real thickness, this is the apparent thickness. Now the traveling microscope has 20 divisions on the in 1 centimeter on main scale, and also 50 divisions of vernier scale is equal to 49 divisions of the main scale. And estimated uncertainty in the measurement. Here uncertainty would mean error. Okay. For all practical purpose, we'll assume uncertainty to be equal to error. So in other words, we have to find the error in the measurement of refractive index. Now as you know that refractive index is given by the real depth upon apparent depth. Okay, real depth upon apparent depth. So what is the real depth given? The student has measured the real thickness as 5.25 mm, whereas apparent depth he has measured as 5.00 mm. So this we can write it as 525 upon 500, which is actually, if you cancel with 25, you have 21 by 20. So this is the refractive index what he has measured, the student has measured. Now if I take this as r by a, okay, r by a, then I can write as per the concept of error, fractional error, because it is product, so we will apply fractional error in mu that is maximum fractional error in mu is equal to fractional error in R plus fractional error in A. When two or more quantities are being multiplied or divided, you have to apply this concept. Okay. So fractional error in R plus fractional error in A. A is the apparent depth. So that is dr by R plus dA by A, and this will be d mu by mu. Then now you see here, the since it is being measured by the traveling microscope, which has a vernier calipers, not calipers, sorry, vernier scale. So we'll apply the concept of error in the measurement of this real depth and apparent depth. So real depth and apparent depth are being measured with a traveling microscope having a vernier scale. So let us calculate the least count of the vernier scale, which will be taken as the what error in the measurement, because you all know that least count error, what is called as least count error, the least count itself is taken as the error. So least count is one main scale division minus one vernier scale division. Okay, so it is one main scale division minus, yet it is given that 50 divisions on vernier scale is equal to 49 divisions of main scale. So one vernier scale, you can say 50 divisions on vernier scale is equal to 49 divisions on main scale. So this is 49 by 50 of main scale division. I hope that is clear. So this will give you 1 by 50 of one main scale division, and one main scale division, you can see it is 1 by 20th of a centimeter, because 20 divisions are there in 1 centimeter. So one main scale division is basically 1 by 20th of a centimeter. Okay. So all the things are in have been measured in mm. Okay. Right. So if you multiply by 10, you can have this as 1 by 100 mm. Multiplying by 10, this is 1000, it's 1 by 100. So therefore this d mu upon 21 by 20, because actual value has been calculated as 21 by 20, is equal to, this will be 1 by 100 upon r is 5.25. Similarly again 1 by 100 in the measurement of error in the measurement of apparent depth upon 5.00. Okay, so this will be, so d mu is equal to, I'll take this to the top, so 21 by 20 into, this will be 1 by 525 plus 1 by 500. I have removed the decimal. Now remember, we have to calculate in terms of 10 power minus 4, x into 10 power minus 4. So let us multiply and divide by 10 power minus 4. So 21 by 20, this LCM will be, let us keep it right now, 1 by 525 plus 1 by 500. I have multiplied and divided by 10 power minus 4. Multiplied and divided by 10 power 4. Okay. Then, so here you can see that 1 0 gets cancelled here, and we are left with 21 into by 2 to take this 1000 here. Okay, so this will be, if you cancel with 25, if you cancel with 25, you'll be getting 20, or I'll do one thing, I'll just take the LCM, not a problem here. So 525 into 500 upon 1025. Okay, then into 1000, 10 to the power minus 4. So this 2 into 500 is 1000, gets cancelled. We are left with this. So this will be 21 into 1025 upon 525 into 10 to the power minus 4. So 25 21s are, and 25 41s are. 21 gets cancelled. We are left with 41. So 41 is the correct answer here. Okay, 41 is the correct answer. Moving on to the next question. A force acts for 20 seconds on a body of mass 20 kg starting from rest, after which the force ceases. Then body describes 50 meters in the next 10 seconds. Value of forces. You can very simply apply the impulse momentum principle here. So impulse momentum principle states that impulse momentum principle states that the impulse is equal to change in momentum. Impulse is equal to change in momentum. So force is required. The force acts for 20 seconds. So this is 20. So change in momentum is final momentum by minus initial momentum. The body starts from rest. So it is basically U is 0. So mass is 20 kg and the speed attained is distance by time, that is 50 by 10. 20 gets cancelled. So we are left with 5 Newton. So correct answer is 5 Newton. Then coming to the next question, the time taken by an object to slide down 45-degree through inclined plane is n times as it takes to slide down a perfectly smooth plane. The coefficient of kinetic friction between the object and the incline is. Right. So this is the inclined plane. Let us say the angle of inclination is theta. Now, when it is smooth, it will accelerate with a equal to g sine theta, we all know. Because when you resolve the forces along and perpendicular to the inclined plane, the only component of weight along the plane which tends to drag the block down is mg sine theta. So acceleration will be due to that. Then coming to the next situation, in case if it is rough, then apart from this g sine theta, that is the component of weight along the inclined plane, there will be a force of friction acting up the plane, which is mu into n. Remember, normal reaction is equal to mg cos theta. Mg cos theta. So you can write this as mg cos theta. So this time the net acceleration in this direction will be the net force in this direction upon mass. So net force in this direction is mg sine theta minus mu mg cos theta whole divided by m. So m gets cancelled here and we are left with what? G you can take common. We are left with sine theta minus mu cos theta. Now as per the question, this acceleration, sorry, time taken in the second situation is n times the time taken in the first situation. Naturally, in the second situation, due to roughness, acceleration will reduce because there is an upward force trying to retard the motion. So the time will reduce. Sorry, acceleration will reduce, so time will increase. So naturally, here, if time taken is t2 and in the first case time taken is t1, then it is given that t2 is n times of t1. Now, we all know that in case of uniform acceleration, starting from rest, the time taken is given by this. So therefore, we can write time taken as under root 2s by a. So since the same inclined is there in the two cases, so 2s will remain same. So t varies inversely as root a. T varies inversely as root a. Therefore, I can write T1 by T2 as under root a2 by a1, or I can write a2 by a1 as squaring both sides. You have t1 by t2 whole square, and here you can see t1 by t2 is 1 by n. From this equation you can see. Okay, now let us substitute the expression for a1 and a2. Substituting for the expression for a1 and a2, I'll drag this to the left so that you can understand properly. From here, a2 is this. So g times of sine theta minus mu cos theta. Then what is a1? a1 is g sine theta is equal to 1 by n square. So we can cancel g both sides, top, bottom. Then you can divide this into two fractions. Subdivide this into two fractions. So finally, after simplification, you have mu cot theta as 1 minus 1 by n square. So this formula you can memorize if you want. In this particular situation, theta is 45 degrees. So cot theta is 1. Cot theta is 1. So therefore, mu is equal to 1 minus 1 by n square. So the correct option is the fourth option. Fourth option is the correct option. That's all in this video, students. Thank you for watching. Thank you so much.